Hello, my lovelies. Let's suffer through some more algebra together. This is Unit 5, Lesson 5, Deviation from the Mean. Average deviation is the average distance from the mean to a data point, and it's used to mathematically represent the spread of the data points. So it's all about how far out the data points are from the center, okay? A larger spread means a higher average deviation, and the more clumped a data set is, the smaller the average deviation will be. It can tell you how spread out a data set is. This is all talking about, we have our mean, our center point of our distribution, and we're seeing how far it deviates, how far the points are spread out. Okay, here's example number 1. What is the average deviation from the mean of the dot plot? So the first step is to find the mean. The mean is the harder, whatever. I can't even think what these are called. It's the hard way. It's counting all the points and then dividing by the number of points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 points. 16 divided by 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. We want this one and the next one because we had an even number of points. If this isn't making sense to you, go back and watch earlier lessons about mean and median. So what we're finding is that the mean for this distribution is 5, okay? So we need to figure out how far each of these points deviates from the center, from 5, okay? So the mean is 5. The next step is to calculate the deviation of each point from the mean. You need to find the difference between the mean and each point on the dot plot. Let's try this first point right here. Since the mean is 5 and the data point is 1, the deviation is 4. 5 minus 1 is 4. It's 4 steps away from our deviation, from our, oh my gosh, from our mean, from our center point, okay? You need to find the deviation for each point from the mean. A table is a good tool to track the ones you've completed and the respective deviations. Now you can see here that we're repeating numbers. These are obviously going to have the same deviation value down here. You'll see why in a second. So 2, how far is it from 5? 1, 2, 3. It's 3 steps away. 3 is 1, 2 steps from 5. So all of these 3's, the value is going to be 2. Okay, for 4, it's 1 step away from 5. Now when we're at 5, there's no deviation. The mean and this point are at the same place, so there's no deviation. Okay, they are at the same location. Now when you get over here, we're not going to deal with any negative numbers. It's just how far away is it, okay? So this is just 1 step away. It's deviating 1, okay? 7, it's deviating 2 steps. 2, 8, it's deviating 3 steps. And 9, it's deviating 4 steps, okay? So this is what the chart looks like, and it should all match, you know, unless I'm a complete idiot. So once you know the deviation for each point, you're going to calculate the average of the deviations the same way you would calculate the mean. So we're going to add all of these deviations together and then divide them by how many we have. Okay, so I'm going to bust out my calculator, pa-ching, because you know I don't try hard. We have 4 plus 3 plus 2 plus 2 plus 1 plus 1. We can skip all of these zeros because they're not going to change anything. Plus 1 plus 1 plus 2 plus 2 plus 3 plus 4. So this is why we had to write out each and every one of these points, is because we have to add each deviation. We can't just do it once if there's 2 dots on 3. Does that make sense? Okay, so that total, the total of all the deviations is 26. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to take 26 and divide it by 16 because that's how many dots we have up here. And the total is 1.625. I am writing so beautifully today, okay? So the average deviation is 1.625. What that means is that if we did all of the math and we solved this problem all the way, on average, each point is 1.625 steps away from our mean, which is 5. Now, why does this matter? I don't know, because it's stupid. but it's talking about how spread out the data is. We can say that the data is about 1.6 or 1.5 steps away from here. Most of the data points are going to fall within 1.5 of here. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. And look at that, there's 8 of them. And there's 8 outside, so it holds true. Okay. Here's example number 2. What is the average deviation from the mean of this dot plot? So our first step is to find the mean. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, we need the 8th point, 1, 2, 3, 4, 5, 6, 7, 8, and the one after it. Our mean is going to be 5 once again. The mean is 5. Now find the distance difference between each data point and the mean. Here is our mean. So we have no points at 1. So there is not point 1 on this table. The first one is at point 2. And it's 1, 2, 3 steps away from our mean of 5. 3 is 2 steps away. 4 is 1 step away. 5 is 0 steps away. They are the same. 6 is 1 step away. 7 is 2 steps away. And 8 is 3 steps away. There are no dots on 9 or 10. Our next step is to find the mean of the deviations. And you do that by adding all of the deviation values together. So with the calculator, we have 3 plus 2 plus 2 plus 1 plus 1 plus 1. Skip all of these zeros, and we're back to 1 plus 1 plus 1 plus 2 plus 2 plus 3, and that gives us 20. We had 16 dots, so 20 divided by 16 gives us 1.25. Our standard deviation is 1.25. That means most of the dots fall within 1.25 of our mean. Okay? My little trick of drawing a line. Let's see if it works again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 dots. Most of them would fall within that standard deviation. This is just something I came up with because I'm a visual person. I don't know if this is real, but that's what that says to me. Recall the 2 examples you completed. These are the 2 different dot plots we looked at. Both examples had a mean of 5. Okay, this is our mean on this one, and this is our mean on this one, but with different deviations. The different deviation represents the spread of the data points. In example 1, the points were spread further apart. You can see that. We have a point at 1 and a point at 9, and we didn't on this one. Meanwhile, the second example is closer together and had a smaller average deviation. This one was 1.625, I think, and this was just 1.25. And you can see, looking at them, that this one is more spread out and this one is pushed closer together. Just because a data set has the same mean, which both of these do, does not mean it's going to have the same average deviation. Okay? Here is question number 1. This is your turn. Okay? What is the average deviation from the mean of the dot plot round to the nearest tenth? Okay? So you can pause the video, figure it out, come back. Our first step is to find the mean. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. 11 divided by 2 is 5.5. 1, 2, 3, 4, 5. That means we have this point. So our mean is going to be 6. Okay? The next thing we're going to do is we're going to make our little chart. Okay? And we have 3, 4, 5, 5, 6, 6, 6, 7, 7, 8, 9. Now how I made this table is we had 1 dot at 3, 1 dot at 4, 2 dots at 5, so I have 2 5s here, 3 dots at 6, 2 dots at 7, 1 dot at 8, 1 dot at 9. Okay. Now we need to figure out how far each of these dots deviates from the mean. Our mean is 6. Okay, so all of these 6s are going to be 0 because they didn't deviate out. 7 is 1 step away from 6. 5 is 1 step away from 6. 4 is 2 steps away from 6. 8 is 2 steps away. 9 is 3 steps away, and 3 is 3 steps away. Now we need to find the average deviation. So we take all of these deviations, grab our calculator, and add them together. 3 plus 2 plus 1 plus 1, skip the zeros, plus 1 plus 1 plus 2 plus 3 gives us 14. And there's 11 of these numbers, 11 dots altogether. So 14 divided by 11 gives us 1.27, and then it repeats and does a whole bunch of stuff. So the average deviation from the mean is approximately, rounded to the nearest tenth, 1.3. All right, here's question 2. What is the average deviation from the mean of the dot plot round to the nearest tenth? Pause it, figure it out, come back. Don't be lazy, don't cheat. Don't have just me do it, because you know I screw up all the time. First thing we need to do is find the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5.5. 1, 2, 3, 4, 5. Shoop. There's our magic number. So our mean is going to be 6. Let's create our little table. We have 2, 3, 4, 5, 6, 6, 6, 7, 8, 9, 10. Okay, that's all of our dots. Okay. Chonk, 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 chonk. Aren't you having fun watching me draw? Okay. 2 is 1, 2, 3, 4 steps from 6. 3 is 3 steps from 6. 4 is 2 steps. 5 is 1 step. All the 6's get zeros. 7 is 1 step away. 8 is 2 steps away. 9 is 3 steps away. And 10 is 4 steps away. Now let's find the average deviation by adding these together. We have 4 plus 3 plus 2 plus 1. Skip all the zeros. Plus 1 plus 2 plus 3 plus 4. That gives us 20. I think this was 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 20 divided by 11 gives us 1.81818181. We're rounding to the nearest tenth, so we have 1.8 for the standard deviation. These are questions that are at the end of your lesson, so just write your answers down, and then when you go and take your assessments, you can enter your answers in. Practice question number 1. Complete the table to find the deviation of each data point. This table shows the mean of a data set, and the mean is always the same number through the whole thing because it's that center balancing point, okay? And the individual data points, and requires the calculation of the deviations for each data point from the mean, okay? So pause it, figure it out, come back. Now, if you're visual like me, this is what it's going to look like. Our mean is 9.25, okay? It says we have a data point at 7, we have a data point at 9, we have a data point at 9.5, and we have one at 12, okay? So it's going to look something like this. There's a data point here, 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 and here. So if that helps you, go ahead and draw it out. What we're trying to figure out is if this is our mean, this is our balancing point, okay? How far away is 7 from that, okay? So 7, this would be 8. So 7, 8, 9, 2, and a 2.25. This one would be 2.25, okay? The difference between 9 and 9.25 is 0.25, okay? Difference between 9.5 and 9.25 is 0.25, and the difference between 9.25 and 12 is, if we put 0.75, that's going to take us to 10, and then 2 holes will take us up to 12. That's what it should look like. I hope you were listening because these numbers can't be read. Here's practice question number 2. Data set A and data set B both have a mean of 9.25. Calculate the average deviation from the mean of each data set. Pause it, figure it out, come back. For my sake, I'm going to circle the mean. So the difference between 7 and 9.25, let's work with just data set A right now. The difference between that is going to be 2.25, okay? And then between 9 and 9.25 is 0.25. And then we have another 0.25 because we have another 9. And then we have 12. So we have 0.75, is going to make 10. Okay, so here's for data set A. We're going to add these together. 2.25 plus 0.25 plus 0.25, woo, fat fingered it, plus 2.75 is 5.5, and we're going to divide that by 4 because we had 4 data points. That's going to give us, it doesn't tell us how far to round because, you know, it loves us. So the whole number is 1.3, come back calculator, 75. I'm guessing it will probably want you to round to the 10th. So if you enter this and it tells you no, I would try 1.4. If it tells you no to that, then I would try 1.38, and then you're probably out of tries. Okay, this is all for A. Let's go ahead and do data set B. Difference between 6 and 9.25 is 3.25. Difference between 8 and 9.25 is 1.25. Between 10 and 9.25 is 0.75. Between 13 and 9.25 is 0.75. We'll take it to 10 and then 3. Let's add these together. We have 3.25 plus 1.25 plus 0.75 plus 3.75. That gives us 9. Divide it by 4 because that's how many data points we had. And this one is 2.25 for the whole number. If it wants you to go to the 10th, it would be 2.3 because you're going to round up from this 5. Okay? Here's practice question number 3. A soccer team tracks the number of goals they score in a game on the dot plot. Complete the table to record the deviation of each data point. Pause it, figure it out, come back. Okay, so the first thing we have to do is figure out our mean. Doesn't do us any good to have data points if we don't have a mean. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5. 1, 2, 3, 4, 5. So our center point, our mean, is going to be 3. So data point 1, okay, it's right here. It is 2 steps away from 3. Okay. Data point 2 is 1 step away from 3. 3 is 0 steps away from 3. 4 is 1 step away from 3. That's all you have to do for number 3. Okay. Here's quick check question number 1. I will not give you the answers to these, but I will tell you how to find the answer. 5 friends recorded the number of action figures each friend has. The following is the data set recorded. Which of the following correctly calculates the average deviation from the mean number of action figures? So you're going to do all the steps that we've been doing up to this point. First, you're going to calculate the mean, and you're going to do that by adding each of these numbers together, 7, 9, 10, 11, 11. Take that answer, divide it by 5, and that's going to give you your mean. Okay? Then you're going to make your little table, and you'll have 7, 9, 10, 11, 11, and you're going to find how far these points are from the mean you calculated. And you'll write them here, which will give you your deviations for each point. And then you're going to find your average deviation by adding each of these numbers and dividing by 5. Okay? These are probably shuffled, so make sure you find the right answer, not just go, oh, it was number 3 on her video, so it must be number 3 on mine. No, use your brain. Quick check question 2. Which of the following correctly calculates the average deviation from the mean number of goals per game scored by soccer team B? So again, you're going to find your mean. You're going to do that by counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the middle number and then figure out which one of these is your mean. Then you're going to make your table, which is going to go 2, 2, and then however many 3s, and then however many 4s. Write down how far each point is deviating from your mean. Then add these together, divide by however many points you have, and here they are. This 7 shouldn't be here. That's a typo. Okay. Second half of the lesson. Here's a check-in, true or false. The smaller the deviation, the more spread out the data distribution. So if your deviation is a small number, then the data distribution spread out? That's false. Small number means it's all clumped together. Big number means it's spread out. Example number 2. Consider the descriptions of the following 2 graphs. What graphs? How did I not have graphs? It's not even showing up where it normally shows up. and compare them. Oh, they're just right here. There are no graphs. It's faking me out. What can you tell about the two graphs? So graph number 1 has a mean of 70 and a deviation of 1, and graph number 2 has a mean of 70 and a deviation of 4. So when you're analyzing the descriptions, the first thing you should compare are the means of both data set. And what that tells you is the means of the data are equivalent, meaning the graphs will have the same balancing point. Okay? The second graph has a deviation that is 3 points higher than the first graph, meaning this second graph is going to be further spread out. So it's going to be longer, and this one's going to be shorter and more clumped. This top one is going to be shorter and more clumped. Here's a check-in. What does it mean for a data set to have a large deviation? So if you figure out the standard deviation or average deviation, and it's a big number, what does that mean? It means the data points are very spread out. You're going to have something that looks more like this with data points than something that looks more like this. That's like shorter. Yeah, whatever. Question number 1, your turn. Given the following description, compare the graphs. Pause it, figure it out, come back. So first, let's look at the means. This one has a mean of 8 and a mean of 10. So if I'm drawing these, okay, one's going to have the mean be at 8, and one's going to have the mean be at 10. So they have different centers, okay? But if you look, they have the same deviations. So that means they're going to be spread out exactly the same, okay? One will just be like kind of to the left, and one will be kind of to the right. That's it, okay? I don't know how they expect you to answer that, but you know, whatever. Both graphs have the same average deviations but different means. Since both graphs have the same average deviations, they are spread out equivalently around the mean. The difference in means will change the location of the center of the graph. Graph 2 is 2 places to the right compared to graph 1. So what I just said. Question number 2. Given the following graphs, compare the average deviations. This is all you. Pause it, figure it out, come back. First thing we have to do is figure out the mean for both of these, okay? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Half of 13 is 12.6. 6.5. 1, 2, 3, 4, 5, 6. So there's our center, which means that's going to be our mean for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Okay, and both of these you could find the center just by looking at it because they're symmetrical, but you know, I did it the complicated way for your sake. Okay, so there's our means for each of these. Now we need to figure out the deviations, okay? I'm going to go ahead and just use, I can't because I have to repeat it. Let's do the first one. Oh my goodness, we have 1, 2, 3, 5, 5, 6, 6, 6, 7, 7, 9, 10, 12. And our mean is 6. So 1 is 5 steps away, 2 is 4, 3 is 3, 5 is 1, 5 is 1, 6 is 0, 6 is 0, 6 is 0, 7 is 1, 7 is 1, 9 is 3, 10 is 4, and 12 is 6. Grab our calculator, add all those together. 5 plus 4 plus 3 plus 1 plus 1 plus 1 plus 1 plus 3 plus 4 plus 6. I believe there was 13. 3, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 29 divided by 13 gives us 2.23. Okay. This one is 2.23. And it wants us to compare these standard deviations. Let's figure out this one. We have 3, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 5. 3 is 1, 1, 1, 1, 0, all the way across all these 4s. 1, 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Standard deviation, 8 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 8 divided by 13 gives us 0.62 if we round it. 0.62. Okay, so comparing these deviations, this one is much more spread out than this one, which we can obviously see. Wow, it's amazing, isn't it? The first graph has a larger average deviation because it is more spread out. We could have said that by just looking at the pictures, but we did all the math. Here is practice question number 4 at the end of the lesson. Compare the deviations in the data sets and determine which has the larger average deviation. Enter the option number of your response. Pause it, figure it out, come back. All right, just looking at this, I'm guessing this one's going to have the larger average deviation because I think it's going to have more numbers, but you know, let's actually figure it out. We have 2 plus 1 plus 1 plus 1 plus 4 plus 3 plus 2 plus 2 plus 3 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 19 divided by 9 gives us 2.1. And that repeats forever, but I'm just rounding it. Let's do the next one. We have 2 plus 3 plus 0 plus 2 plus 1 plus 1 plus 2 plus 2 plus 3 gives us 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. 16 divided by 9 gives us 1.8 if we round it. So this one is more spread out and it has the larger average deviation. Here's practice question number 5. Compare the deviations and determine which graph has the larger average deviation, graph 1 or graph 2. Okay, so in order to figure this out accurately and completely, you have to do the math. You don't want to just guess. So let's find the mean first. 1, 2, 3, 4, 5, 6, 7. So 3.5. 1, 2, 3.5. So this right here is going to be our mean on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And the next one, so it's going to be, this is going to be our center, our mean for this one. Okay, let's figure this out. We have 18, 20, 20, 20, 21, 22, 22, 22. Okay. Let's figure out the deviations. They're all from 20. So this is 2, 0, 0, 0, 1, 2, 2, 2. Let's get our calculator out. We have 2, 4, 6, 8, 9. Divided by 1, 2, 3, 4, 5, 6, 7, 8. 9 divided by 8 gives us 1.125. Okay, let's do our next one. We have 0, 2, 2, 2, 2, 4, 4, 4, 5, 5. I ran out of room. I do that to myself a lot in case you haven't noticed. Standard deviation is 3, so 3, 1, 1, 1, 1, 1, 1, 1, 2, 2. We have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gives us 1.4. Okay, so which one has the higher average deviation? The number of siblings per student. One does. Okay, here is quick check question number 3. Given the following descriptions, which of the following correctly compares the average deviations and describes how the center of graph 1 relates to that of graph 2? Okay, so we're going to look at these. The mean on graph 1 is 7 and on graph 2 it's 10, and they have the same deviations. So what that's going to mean is just like what we looked at before. 1 is going to have a center at 7 and 1 is going to have a center at 10. but they're going to be equally spread out. Okay, so find the correct answer. Choop. Quick check question number 4. Which of the two graphs has a larger average deviation? So first, you need to find the mean, find our center balancing point by 1, 2, 3, 4, counting these, finding the center point, okay? Then you need to find find the deviation for each point by making your little table, okay? These are not going to be such little tables. Then you're going to take all of those deviation points, add them together, and divide by how many dots you have, and then you'll have your deviations for both of these tables. It is possible to tell which has the larger average deviation, so that is not a correct answer. Okay? Quick check question number 5 says, compare the data sets in the tables. Which of the following correctly describes the relationship of their average deviations? Okay, it is possible to tell. Don't fall for that one. You're going to add these together and divide by the number of data points you have. You'll have your deviations, and you can answer this question. And don't you just love the dramatic shoes they have on Canva? I would absolutely break my neck if I tried to walk in these.